Today we're going to dive into an incredible story about how one of the smallest errors you can possibly imagine, literally a single typo in our DNA, can kick off a massive, lifelong battle for millions of people. This is the story of sickle cell anemia.
And that's really the big question we're going to tackle. It just sounds impossible, right? How can one tiny little mistake have such devastating, widespread consequences? Well, let's unravel this medical mystery together. Okay, so first things first, what exactly is sickle cell anemia? At its heart, it's an inherited blood disorder, and it completely changes the shape and, the job of your red blood cells. Instead of being nice and round and flexible, they become hard, sticky, and shaped like a C, kind of like a farming sickle. And that shape, that's where all the trouble begins. To really understand this, we have to go way, way back, all the way to the beginning. We have to look at the origin story of this disease, which all happens on a microscopic scale deep inside our own DNA. So, the whole problem can be pinpointed to one specific spot, a gene called the HBB gene. Now, you can think of this gene as the instruction manual for building a really important protein called hemoglobin. That's the stuff inside your red blood cells that's in charge of carrying oxygen all over your body.
And right here, this is the exact typo. In the instruction manual for normal healthy hemoglobin, the code asks for an amino acid called glutamic acid. But in sickle hemoglobin, a single tiny error swaps it out for a different one called valine. That's it. That one little switch is the trigger for the entire disease. It's kind of mind-blowing.
So how does a person get this faulty gene? Well, it's what's called an autosomal recessive disorder. And what that means is you have to inherit a copy of this mutated gene from both of your parents to actually have the disease. If you only get one copy from just one parent, you have something called sickle cell trait. You're a carrier, you usually don't have symptoms, but you could pass that gene on to your kid.
Okay, so we've got the genetic typo, but how does that little flaw on paper, so to speak, turn into a real physical problem? Let's take a look at how that single amino acid swap actually transforms the blood cell itself.
And wow, when you see them side by side, the consequences are just so clear. A normal red blood cell is a little masterpiece, right? It's round, it's flexible, so it can squeeze through the tiniest blood vessels, and it lives for about 120 days. The sickle cell, on the other hand, it's C-shaped, it's stiff and rigid, and its lifespan is shockingly short, just 10 to 20 days. Just let that sink in for a second. That's a drop of up to 90% in the cell's lifespan. Your body is basically in a constant state of emergency, trying to replace these cells, but it just can't keep up with how fast they're dying off. And this constant, chronic shortage of red blood cells, well, that is exactly what anemia is. It's why people feel so tired, get short of breath, because the body just doesn't have enough healthy delivery trucks to get oxygen where it needs to go. Okay, so let's zoom out and see how these faulty cells put the entire body under siege. And the problems go way beyond just feeling tired. It's really a cascade of consequences that can mess with almost every single part of the body. So just imagine this. What do you think happens when these stiff, sticky cells, which are supposed to be flowing smoothly, start trying to navigate the super narrow highways of our blood vessels? You got it. They cause traffic jams. Huge, painful, and really dangerous traffic jams.
And these cellular traffic jams show up as a whole range of awful symptoms. We already talked about the anemia, but the one most people know about is the agonizing pain crises. It can also cause really painful swelling in the hands and feet, especially in little kids, frequent infections, and it can even delay growth.
And let's be really clear, this isn't just a dull ache. A pain crisis, the technical name is a vaso-occlusive crisis, is a full-blown medical emergency. It's this sudden, severe pain that happens when a clump of sickle cells totally blocks off blood flow, basically starving a part of the body of oxygen.
So you can imagine, with a disease this severe, managing it is a full-time job. Let's look at the kind of daily defense that patients and their families have to put up just to fight back against these symptoms.
Being proactive is absolutely the first line of defense. And it's all about things that a lot of us just take for granted. Staying really well hydrated is critical because it helps keep the blood flowing a bit more smoothly. Avoiding extreme temperatures, preventing infections with daily antibiotics and vaccines, and carefully managing physical activity are all essential parts of trying to stop the cells from sickling and causing a crisis.
Medically speaking, the fight is happening on two fronts. On one side, you have treatments for managing the symptoms. Things like medications to reduce how often crises happen, strong pain relievers, and blood transfusions. But on the other, more hopeful front, you have these amazing therapies that aim to fix the root cause of the disease itself.
And that right there brings us to the most exciting part of this whole story, the frontier of modern medicine, where scientists are not just trying to manage sickle cell anymore, they're actually trying to fix that faulty code we started with.
Now, for a long, long time, the only real cure was a bone marrow or stem cell transplant. It works, but it's super risky, and you need a really closely matched donor, which, a lot of people just don't have. But now we have gene therapy. These are brand new treatments that can go into a patient's own cells and directly fix the HBB gene, basically correcting that single typo that started this whole mess.
And the recent approval of these gene therapies is just a massive moment. This isn't just a small step forward. This is a huge medical advance that offers real, genuine hope to millions of people who've been battling this absolutely devastating disease their entire lives.